This is for Math 1710, Section 2.4 on linear functions, which were discussed to some degree in a previous section. But a linear function is a function that can be written as f of x equals ax plus b, where a and b are real numbers, but a can't be 0 because if it were, you would have no x term. And the domain and the range are both from negative to positive infinity, and when you graph this function, it turns out to be a straight line. We have previously discussed graphing linear functions using intercepts, but I want to do a few more examples with that in this section. To find the x-intercept, you let y be 0. To find the y-intercept, you let x be 0. Then it's advisable to find one additional point, and you can choose any x value and find the corresponding y value to do that. It's like establishing an XY table. You may be familiar with that terminology. So for our first example, we'll be graphing f of x equals negative 2x plus 6, which is the same as y equals negative 2x plus 6. So to find the x-intercept, we let y be 0, so 0 equals negative 2x plus 6. Add 2x to both sides, we get 2x equals 6, and divide by 2 and we get x equals 3. So that's the x-intercept. To find the y-intercept, we let x be 0, so y equals negative 2 times 0 plus 6, so y equals 6, and that's your y-intercept. Then we'll choose one additional point for an xy table. Let's choose, say, 1. If we do that, we have y equals negative 2 times 1 plus 6, so that equals 4. So for y value, we have 4. So we have this point, and this point that we could put on our coordinate system. So x is 3, 1, 2, 3 right there. Y is 6, 1, 2, 3, 4, 5, 6. And then 1 and 4 would be right there. Finding that third point helps you to be sure that all the points line up in a straight line, and then you connect the points, completely fill up your graph and put arrows on the end of each of the graph, and then label it f of x equals negative 2x plus 6. So that completes the graph for that function. Our next example says to graph f of x equals negative 3. You'll notice there's no x term in this, and we realize that that's the same as y equals negative 3. So what we do is count down to negative 3 on the y-axis, put a point right there, and we could count down anywhere from the x-axis 3 spaces, anywhere at all. Every one of them, the value of y is negative 3. So we can connect those points, and that becomes our graph. So f of x equals negative 3. We label it. So what that means is that this is a horizontal line. There are a lot of things in math that are opposites. So when we think of y, the y-axis is vertical, but the line y equals negative 3 is horizontal, so that would make it the opposite. We also have one where we have to graph, x equals negative 3. So again, we make a graph. we count off -3, make that point, and there's a point here, there's a point down here, and there's points everywhere along there where x is -3. So if we connect those, we get this graph for x equals -3. Notice that the x-axis is horizontal, but this line is vertical. So again, we have the opposite situation. X equals some number is vertical, y equals some number was horizontal. All right. As we continue on here, we want to talk about something called the standard form of a linear function, which is ax plus by equals c, all capital letters for a, b, and c. A, b, and c are real numbers. We normally try to reduce any equation of this form so that a, b, and c are what we call relatively prime, which means that the only number that goes in all three of them is 1. So if we had 2x plus 4y equals 6, we could reduce that down by dividing everything by 2 and get x plus 2y equals 3. The equations are the same, but this one is considered to be in standard form because the 1, 2, and 3 are relatively prime. But let's go ahead and do our first example here. 4x minus 5y equals 0. And we're going to graph this using the intercept method. To find the x-intercept, we let y be 0, so that's 4x minus 5 times 0 equals 0. So this basically crosses off and we get 4x equals 0 and x equals 0. So when y is 0, then x is 0. And if we do the y-intercept, put 0 in for x, that'll be 4 times 0 minus 5y equals 0. This would cross off and we'd get y equals 0. So we actually end up with only one point, the 0, 0. So for our xy table, this time we really need to choose 2 points instead of 1. So since we're going to have to end up dividing by either 4 or 5, we need to use some value for x that is, say, a multiple of 5. So I'll use 5, and since I need a second point, I'll use -5. If I put a 5 in to the equation for x, I get 4 times 5 minus 5y equals 0. So 20 minus 5y equals 0. 20 equals 5y, and y equals 4. So we can put a 4 right there. If we put a -5 in for x, we get 4 times -5 minus 5y equals 0. So -20 minus 5y equals 0. -5y equals +20 when you add 20 to both sides, and then y would be -4. So we'll put that -4 there. So we have this point, and we have the 0, 0 point. So we'll put those on a coordinate system. There's the 0, 0 point. We have 5, 1, 2, 3, 4, 5, and 4. Will be right there. And then we have -5 and -4, which would be about right there. So again, you can see the points line up. So we connect them with a straight line, and at one end or the other, we can put 4x minus 5y equals 0 to label the graph. So we've done that by the intercept method, and we're going to do one other equation like this by the intercept method, which is 2x plus 5y equals 0. I'm sorry, equals 10, not 0. So to get the x-intercept, we put 0 in for y equals 10. Cross that off. 2x is 10, so x is 5. So that's the x-intercept. To get the y-intercept, we put 0 in for x. 0 in for x. 2 times 0 plus 5y equals 10. Cross this off. 5y equals 10, so y equals 2. So there's your y-intercept. And then we can select one other point. I'm going to choose a multiple of 2. Or a multiple of 2. So I'm going to try 2 for x. I put that in there. 2 times 2 plus 5y equals 10. So 4 plus 5y equals 10. So 5y equals 6, and y equals 6 over 5. So I ended up with a fraction, and I'll put that up here, right here, 6 over 5. If I had chosen a multiple of 5, I would get 2x plus 5 times 5 equals 10. So 2x plus 25 equals 10. So 2x equals negative 15. X equals negative 15 over 2. So I still get a fraction. So I just didn't select a number for x that gives me a whole number for y. But we can deal with that. We put x equals 5, 1, 2, 3, 4, 5. That's your x-intercept. Y equals 2, 1, 2 for your y-intercept. And then I'll put in 2 and 1 1/5, which would be about right there. And I'll connect those 3 and label it 2x plus 5y equals 10. So on this particular point, we had to kind of estimate, but that's okay. It turned out to be in a straight line like we wanted. The next thing on page 18 of your notes is the slope of a line, which is the numerical measure of how steep a line might be that you graph and which way it slopes, either up or down. We can of course have the slope formula: y equals y2 minus y1 over x2 minus x1, using the coordinates of the x's and the y's of the 2 points. We also know that this is the same as rise over run, which rise is your vertical change and run is your horizontal change in the line. And you also may be familiar with this as well, called delta y and delta x, where delta is a Greek letter meaning the change in. But we call this the slope formula, and these are variations of it. We can find the slope formula then. If I have negative 4 and 8 as one point, and 2 and negative 3 as another point, I can find the slope between those 2 points. I'll first label this one x1, y1, and this one x2, y2, and it makes no difference which one you label which way. But the slope then would be y2, negative 3, minus y1, which is 8, over x2, which is 2, minus a negative 4, so that becomes negative 11 over 6, which is negative 11 over 6. So there's the slope of the line that connects these 2 points. We have one other example of finding the slope using I skipped one. There's 2 and 7 and 2 and negative 4. So label x1, y1, x2, y2. So m will be negative 4 minus 7, and then on the bottom 2 minus 2. So we get negative 11 over 0. Since we have division by 0, that makes the slope what we call undefined, because division by 0 is undefined. And then one last example, 5 and negative 3, and negative 2 and negative 3. If I label this x1, y1, x2, y2, m will then be negative 3 minus a negative 3 over negative 2 minus 5. So this time we get a 0 in the numerator and negative 7 in the denominator, but that equals 0. That means that the slope is equal to 0. It does not mean that there is no slope. But back here where you had 0 in the denominator and the slope was undefined, that means you do not have a slope. Here we do have one, but it's 0. So there's a distinction between undefined and slope being 0. All right, now we want to next look at how do we find the slope when we have an equation instead of 2 points like we just did. Well, if we take this example, 4x plus 3y, and follow the steps in your notes, it says to solve, first of all, solve for y. So we'll subtract 4x from both sides. This column crosses off, and we get 3y equals, put the x term first, negative 4x, and then plus 12. Then divide by 3 on each term, and we get y equals negative 4/3 plus 4. Negative 4/3 x, I'm sorry. And the negative 4/3, that happens to be your slope, m, because this is what we call the slope-intercept form, y equals mx plus b, the slope-intercept form. So anytime you have an equation that's not solved for y, if you'll solve for y and get it in this format, you'll have the slope by looking at the number in front of the x. We can also use the idea of a point and a slope to graph an equation or a function. So here we have an example where the graph passes through negative 1 and 5, and it has a slope of negative 5 over 3. So this is your x1, y1, and we're going to locate that point on the graph, a negative 1 and a 5. 1, 2, 4, 5. So our point would be right there. And then this is your rise and your run number. I'm going to put the negative with the numerator. If you have a rise of negative 5, that means you actually go down 5. So you count 1, 2, 3, 4, 5. And then the run number is 3, so you count over 1, 2, 3. And then you end up right here. So you started here, count down 5, count over 3, and then you connect these two numbers, or these 2 points rather. Fill up your graph with the line, put arrows on each end and label it. Well, we can't really label it because we didn't have an equation. But we have the line there based on a point and its slope. We also want to notice that the average rate of change that this line creates is something that we can use to solve certain kinds of problems. If you have an interval from A to B, that is on the x-axis, say maybe A might be there and B might be there, and we can then take the y value, this is called f of A, and this is called f of B. In other words, that's what you get for y when you put A into the function. So if we took f of B and subtracted f of A and divided by B minus A, notice that B and A come in this order and they come the same order down here. That gives us what we call the average rate of change. So here's an example that we're going to look at right here. It says in the year 1980, the average rate for basic cable TV was $7.69. In 2008, the rate for cable went up to $46.13. So these are like points. These are your X's, and these are your Y's. So here, this could be like A and B. This would be f of A and f of B. So putting them into the function, or the formula, f of B is 46.13, f of A is 7.69, and then we have 2008 minus 1980. All right, so we'll calculate that out. If we subtract 46.13, subtract 7.69 from that, we get 38.44, and on the bottom we get 28, and if we divide that out we get 1.37, rounded off to the nearest two decimals because we're dealing with money. So that what that means is that the rate for cable TV changed, in this case increased, about $1.37 a year for those 28 years. So we'll put per year right here. All right, the very last thing in this section has to do with what we call mathematical modeling, where we can use various types of functions in actual real situations. And first one of those is called the cost function, which we call C of X. The cost is a function of X, and the formula is mx plus b, where m stands for the cost of each item that you produce, like in a manufacturing business. X is the number of items produced, and b is what we call our fixed costs, like utilities and rent and so on, because utilities and rent stay the same no matter how many you produce. That's why it's called a fixed cost. We also have what we call revenue, which is called R of X. Revenue is how much you get for selling your products that you're manufacturing, and R of X is based on the price times the number of items. So the more items you sell at a particular price, the more revenue you have. And then the last thing you want to think about is how much profit will you make? Well, revenue is how much you get for selling it. Cost is how much it costs you to make it. If you subtract those two, R of X minus C of X, you get your profit. So here we have an example where we're going to assume the cost to produce an item is a linear function, and all the items that you produce are actually sold. The fixed costs are $1,500, so that's what we call B in the first equation there. Then we have variable costs, $100. The variable costs were the M in the first equation. The items will sell for $125, so that's the price. And what we are looking to do is find a function or a model for the cost, which is part A, the cost. So that's C of X equals mx plus b. So C of X equals M, which is 100. X, we don't know. And B is 1,500. So there's the cost function. The second one is the revenue function. So R of X is P times X. So R of X equals the price, which is 125X. And then the profit is the difference of the two. So we do R of X minus C of X. So R of X is 125X minus C of X, which was the 100X plus the 1,500. We need to put that in parentheses because there's a minus here and that'll change the signs. We can simplify this to 125X minus 100X minus 1,500. Combine these two and we get 25X minus 1,500, and that's your profit function. Then there is a question associated with this problem where we have to do some calculations, because they want to know how many items must be sold to make a profit. Now, to make a profit, the revenue has to be larger than the cost. So the revenue function has to be bigger than the cost function. So the revenue function, as we said, was 125X. The cost function, we said, was 100X plus 1,500. If we would subtract 100X from both sides, this column would cross off here. We get 25X is greater than 1,500. Divide by 25, and X would have to be greater than 60. So any amount of items that you produce over 60 items will give you a profit. Anything less than 60, you won't make a profit, you'll take a loss. But again, you'll see that there's an assignment at the end of this section in your notes, but you will not do that assignment. You will do the assignment on the Pearson website. Thank you.